gonna start all the way over, but so for those of you joining me on YouTube, I started teaching and I forgot to press record. So I just will have this kind of up for a second, review of what we just talked about. Median is the vertex and the midpoint. And when you have 3 or more lines intersect, they're called concurrent. And the point at which they intersect is point of concurrency. So take a second, pause it if you need to get this written down. Okay, that's on me, my bad. But I caught you before we got into the meat of the lesson, which is important. So the meat of the lesson today is about what happens when we draw 3 medians on a paper. They have a special name. They're called the centroid of the triangle. So I'm gonna actually write this next to it because I think centroid's kind of hidden in all those words. So I'm gonna write median and I'm gonna write centroid next to it. So the theorem that we have about this is that the medians of a triangle are concurrent at a point, and that point is the centroid. And that is 2/3 the distance from each vertex to the midpoint of the opposite side. Okay, that sounds like a lot of crazy words. In shorter terms, and a different way of saying it, the centroid divides each median into a 2-to-1 ratio. And the median is closer to the side of the triangle than it is to the vertex. Everybody with me? Okay, so if I go look at this picture, let's say I'm looking at DJ. That's a median, right? It goes from the vertex of D, it goes to the midpoint of J. This whole thing is split into thirds. The small third is C to J. I can write like 1/3 next to it. And then DC is like 2/3. The way the ratio comes from is essentially if I just got rid of those denominators, if I got rid of my 3's, it would be a 2-to-1 ratio. I do think it's helpful to think of it as thirds though, so I like to kind of intro that as thirds. We're gonna work through a couple different ways, and on your homework, you'll have more practice on this. So we'll do more practice later, but I'm gonna give you just an intro to this. So if I tell you DJ, I can also tell you what CJ is and what DC is. So CJ is the entire length. That's 15, I just told you. What's 1/3 of 15? 5. And then if the whole bit is 15 and we had 5 for the 1/3, how much is left? That's 2/3 of that shape. 10. 10 and 5 are a 2-to-1 ratio because 10 is twice 5. So if I had the small number, I can just multiply it by 2 to get that bigger number. And I took the whole number. So I took the whole and I divided it by 3 in order to get that like short segment. I always want to get that short segment and then I can move it around from there. But if I don't have the short segment, I want to get to the short segment. Okay. So we found that CJ was 5 because we did 15 divided by 3. And then I did 5 times 2, or essentially 15 minus 5, and I got 10 for DC. So that's if I give you the whole bit. If I give you the small bit, which is what I'm doing next, I'm now looking at this segment, FH, and I'm focusing in on HC. And I'm going to tell you that that's 7. Okay. How do I find the medium length or the longer length inside if the short one is 7? Times 2, it's a double, so that's 14. And then how much will it be all in total? 21. In order to get 21, you can add 14 plus 7, or you can think that the short length is 1/3, so multiply that by 3, that's 21. 7 times 3 is 21. So H to F is 21, HF is 21, and C to F is 14. Are we doing okay so far? Okay. And then the last one, I think this is the hardest one to think about. It's not that hard, but I think it's the like kind of weirdest one to look at, is if I have CE and I'm looking at segment GE and CE is 18. Yeah, Ben?
Wait, so how do you get 14?
I did 7 times 2 because I took the short length times 2. You also could have, if you knew 21 easier, if you knew what the whole length was, you could just say, okay, well, this is 7 and this is 21. So how much is left for the other one? There's a couple ways we can attack this problem. Okay, so this problem that I'm looking at now, EC is 18. I think this is kind of the weirdest one when I give you the 2/3 side, Alea. The smaller side is this one right here. It's GC. Oh, I didn't mean to do that. Yeah, GC is the smaller one. Not by 3, because this isn't the whole. What are you dividing by, Chase? By 2. So since this is like the medium segment, we're going to divide it by 2 to get 9. And then I know 9 plus 18, or you can think of it as 9 times 3. That's 27. So GC is 9 and GE is 27. All right. That's kind of funky stuff. A little bit of math, a little bit of thinking. Bless you. Anybody questions yet? Okay, bless you again. A couple other things, properties of my centroid. I just told you that the centroid divides the median into a 2-to-1 ratio. So we kind of talked about that. The other thing that's like most interesting about this, and this is why we talk about it, is the centroid is what we call the balancing point of the triangle. Balancing point. Okay, this kind of dates me when I say this, but when you guys were little, when I was little at least, there was like a toy that we had that was like a bird that had its like wings out and it had a little beak, and you'd put your finger on the beak and like the bird would balance on your finger. Does anyone know what I'm talking about? Naomi's nodding her head. Avery's nodding her head. Okay, Gavin. So for those of you who are like, I have no idea what you're talking about, I can try and Google it and put it on the board. And I don't think this toy did anything else. I literally think we balanced it. Like, I don't think it like flew. I don't think we like did anything with it, but I remember having like a bird that balanced its little beak on your finger and then it would like stay there. Every object has a balancing point. Like your iPad or your phone, it's pretty much right in the middle, but there's a point on your iPad that you can balance it without touching any other points. I don't know if my finger's strong enough, but like here, there my iPad has a balancing point. It's pretty easy for like a square or rectangle because it's basically in the middle. The medians, when you do draw all your medians, I would argue if I had like a big triangle, the point at which I would balance that triangle on just my finger would be the centroid. So that's kind of the cool thing about it. So that's why we're doing that. Now, if you don't have, like if we didn't draw all of our medians to find the centroid, we can find it algebraically using endpoints. So the centroid always lies inside of the triangle, right? There's no way I'm going to balance my iPad if my hand's out here, right? That's just like physically impossible. The way physics works, gravity's going to take that down. So the centroid is always inside of your shape. And it can be calculated using the vertices of a triangle using this formula. Does anyone notice anything about this formula? There's 3 x's. Good.
Oh, it's just like
It's a lot like the midpoint, right? So it's like the midpoint, but it has 3 x's because we're essentially doing the midpoint of a triangle. And I care about all 3 x's and I care about all 3 y's. So we're dividing them all by 3 each time, not by 2 or by anything else. So I like to write like the midpoint formula next to it so that it seems more familiar to me because we're used to doing the midpoint formula. We might not be as used to doing some of the other formulas. All right, let's use that and let's find the centroid of the triangle below us. However, letter A wants us to sketch first. So we're going to sketch and we're going to see if the answer we get when we draw is the same as the answer we get when we calculate algebraically. So when I draw this, I'm going to go from the vertex of one angle to the midpoint of the opposite side. And I actually nicely labeled them with G, H, and J. So I'm just going to connect my line here. I'm going to connect from D to H and from F to G. Go. That's my centroid. Based on drawing, what would I rate my ordered pair of my centroid to be? 5, 3, good. Now I'm going to prove using algebra that we'll get the exact same answer using our formula. as Lila brought up, it's a lot like the midpoint formula. So I'm gonna take all my x's. So I'm gonna do 1 plus 5 plus 9 divided by 3. And then I'm gonna take all my y's. I'm gonna do 1 plus 7 plus 1 divided by 3. One plus 5 plus 9 is 15. And 15 divided by 3 is 5. Okay. 1 plus 7 plus 1 is 9. And 9 divided by 3, oh, shoot, that's also 3. Awesome. Sometimes you get such nice, pretty numbers. If you got a fraction, though, that wouldn't be crazy because not every number is divisible by 3. So just whatever your fraction is or your decimal, just get it that and leave it that way. But this one ended up pretty nice. Anybody questions yet? I'm not right now, but I can't remember if the homework has fractions or not. Let's do these next 3 problems, then we're going to go to the back side. All right, this is a little bit of a review. Letter A says, which segment in the diagram is a median? Which one's a median? AD, why? Give me other ways to describe the median. What?
It's going from the
Vertex to the midpoint. There we go. You're not wrong, but like I don't want us getting in the habit of saying it splits it in the middle because like these 2 triangles don't look like they were split down the middle, do they? No, they don't look the same. They don't look congruent. So like I think if it's being split down the middle, like I don't know about you guys, but I grew up with sisters and like everything we did like always had to be equal. Is anybody like that with their sibs? Like we would all like everything was equal. If you got something, I got that exact same amount, not like a little bit more or a little bit less. It was like exactly equal. And like to me, these triangles don't look exactly equal. Their area might be equal, but I can't tell that from here. So I don't want to say it splits it down the middle. Is there an altitude?
Yes.
Where?
No. Yes.
Yeah, let's see.
It is. Yeah.
Of a smaller triangle AF would be, but let's just think about like the big whole triangle we see. So I'll say CF. And then next it says draw the mid segment on the diagram. What 2 points am I going to draw a mid segment between? E and G. I don't think E and G.
C and B.
I don't think C and B.
D and A.
C and A. B and E. A E D.
ED. I love the idea of G, but do we know G is a midpoint? No, there are no congruent marks. So even though G, like you could argue, it looks like it's, no, we don't argue. We know for sure. So we don't know for sure G is a midpoint, but I do know for sure E is a midpoint because of its congruent marks. And I do know for sure D as in dog is a midpoint. So I'm going from D as in dog to E as in elephant, and I'm drawing this line right here. Okay. All right, that's the front side. I'm even going to write ED down here just in case I forget that I drew that earlier. Just helping myself, set myself up for success. All right, flip your paper over. I've got 3 vocab words and I've got 3 drawings. Okay, the last point of concurrency that I really care about that I'm going to teach you about is with the altitudes. The altitude goes through, do you remember what's 2 special things about the altitude?
The right triangle. The right.
Vertex and right angle. So median was vertex and midpoint. Altitude is vertex and perpendicular or right angle. The way this is worded, I'm going to write the word perpendicular because I think it makes the most sense in that blank. But we have been saying right angle a lot, so I am going to put that in parentheses because those are the 2 words we connect. Vertex, right angle, vertex, right angle. That's what we've been saying over and over. All right, the altitude of a triangle is the same thing as the triangle's height. I feel like that's something we use a lot more when you guys were in middle school. We drew an altitude, but we called it the height. I'm just reminding you that to remind you that this isn't really a new concept. We just have a new name for it. We have a grown-up name for this concept you've known about. And it says the triangle or the altitude, excuse me, can be inside, outside, or it can be the side of a triangle. When we draw all three altitudes and find their point of concurrency, that point of concurrency could be inside the triangle, it could be outside the triangle, or it could be on the triangle. So that's why we're doing 3 drawings, because it's going to look different each time. Now, the point of concurrency of an altitude is what we call an orthocenter. Orthocenter. That makes me think about going to the orthodontist for my braces. Now, the only 2 words I taught you today were orthocenter and centroid. Bless you. Median and centroid go together. They both start with consonants. They both start with M and C. Those are consonants. Altitude and orthocenter go together, and they both start with vowels. So that's how I keep it straight in my head. If you have a cuter way to keep it straight in your head, let me know. This is the best way I've thought about. Orthocenter, altitude. I wrote centroid right here on the front, kind of like off to the side with median. All right, so we're going to draw 3 altitudes on each of these triangles, and we're going to find the point at which they intersect. I'm going to start with an acute triangle because that makes the most sense. It's going to look nice and pretty and organized. The other 2 are going to get a little chaotic. So I'm going to pick a vertex. It doesn't matter which one you start with. Pick a vertex, and we're going to draw the altitude from there. So we're finding the line opposite it. That is a right angle. I think that's good enough. Just do your best sketch. In the past, I've gotten like protractors and compasses and all these tools out, so we were like super exact. We truly don't have time for it. So just do your best, make your best guess. Now I have to arrange my paper a little bit, move it around so I can see. There's my vertex. I'm going to draw my altitude. I think it was there, maybe. And then last, I'm going to draw my vertex and my altitude. Once you have 2 lines, the third one should be pretty easy because it should connect really nicely with the other 2. And if it doesn't, if it's 90-degree angle is off that, then your other 2, there's probably something wrong. Okay, so that little yellow circle I did is my orthocenter. I'll zoom back out in a second. And the orthocenter in an acute triangle is inside the triangle. Then maybe one of your lines is not an altitude. And truly, it's just a sketch. So I try my hardest for the first 2 lines that I draw. And then the third one, I just make sure it goes through the other ones. Is that okay? Better?
Miss White,
Maya?
so for these, do you always have to make like lines on the vertexes
Mm-hmm.
or on the vertices?
Yep, so you go from each,
Okay.
all 3 vertexes. Very good. Inside,
Okay.
center, inside. All right, we're gonna do the right triangle next. Do you remember yesterday? I know we did this on the board, so it was like kind of hard to connect with the picture. But do you remember when we had a right triangle? How many altitudes did we like physically see and physically write down? 2, because each of the legs is a altitude. So my very first 2 I'm going to do is just sides of the triangle. So I'm just coming straight down the side of the triangle. It goes from a vertex and it goes where it's perpendicular to the opposite side. Same thing with the other one, goes from a vertex, goes perpendicular to the opposite side. The last one's a little bit tougher. You have to remember to go from the vertex where the right angle is to a point that's perpendicular on the opposite side. You got to make a right triangle. I think that's pretty close. Again, we're just sketching. So if yours is like a little off than mine, that's fine. Just try and eyeball it the best you can. Where's my point of concurrency in this picture? Right where the vertex of the right angle is. Exactly.
Why wouldn't like, why wouldn't it be in the middle?
It will not be in the middle because the 2 legs, they cross the other side. Their altitude is on the edge of the triangle. So they already intersect, these 2 intersect on the edge of the triangle. And the third one comes from that vertex. So when I extend this line out, it also crosses through the edge of that triangle. So I'm going to say orthocenter, and I'm going to say on. I'm going to say this one is on the triangle.
Don't say on, right triangle.
You can if you want to. You can be more descriptive if you want. I'm just saying inside, outside, or on. Those are kind of my 2 or 3 different situations.
Wait, so acute was.
Acute was inside. Mhm. Acute was inside, orthocenters on. Or sorry, right triangle is on. The obtuse triangle is a little funny, so I have a picture drawn for you, and then we're gonna draw our own picture. And this is the last one we're doing today, so stick with me for a couple more minutes. The obtuse triangle, this might be kind of hard to read if you are on paper, or maybe the iPad's harder, I can't remember. The triangle I'm worried about is my triangle ABC right here. One of my altitudes is just through C. So I went from my vertex to a point that was perpendicular on the opposite side. That one was really self-explanatory. If you remember in class yesterday, I told you that altitudes can go outside the triangle. So on a couple of these, if I'm going from point A, if I were to draw a line right now to go to the opposite side, there's no way, like this is not a right angle, right? Do you guys agree with me there? This guy next to it is also not a right angle. So I can't leave it on the inside there. I actually have to extend the line of BC. That's what this little dashed line means right there. I'm extending it out because when I draw my line, I have to come all the way out here in order to get a 90-degree angle.
So what is that?
This B, I haven't done that B line yet. Right now, all I did is come from A and I'm intersecting the side opposite it. Yep, the dotted line extends. It's like if this line were to keep going, it's still going, 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 going. We're gonna do the exact same thing for B. So I'm coming from this vertex. You guys will agree with me again that this does not make any right angles inside, right? Those are definitely not right. So I have to extend this line out in order to find where the right angle is. And that's right here. If you can't find it, I kind of search for it until I'm like, oh, that looks pretty close. That's my right angle. And the point at which they all cross, my orthocenter, is on the outside of the triangle now. My last class, somebody said something like, oh, it's like you're making an acute triangle with all the orthocenters. Sure, if that's what helps you kind of keep it all straight in your head, you can think of it that way. Because the yellow shaded part is the inside of the triangle. So the original triangle to us was that obtuse triangle. So now we're going to draw it out. It's interesting to look at it like this, but now let's actually do it ourselves. So I'm going to come over here, and I usually like to start with my the obtuse angle because that's going to stay inside. That's going to be a normal altitude. So I'm going to go to Y. And if I draw a line perpendicular to it, it's about here, I think. I do want you to extend that line past Y though, kind of up here into the ether, because that's where all the other lines are going to cross it. So I extended a little bit outside my triangle. Next, I'm going to go to angle X. And again, we know if I draw it inside the triangle, it's not going to fit. It's not going to make 90 degrees. So I'm going to extend my side opposite. I'm going to extend XY a little bit, or sorry, ZY a little bit. Really, I'm trying to be good. Okay, that's good as good as it's going to be. Oh, I can do one on notability. I think that's pretty close to a right angle. And then same thing from Z. Again, I'm going to have to extend out my XY line a little bit. I'm actually going to do this to make a dashed line. Close enough. All right, and then I'm going to extend from here. And it's about right about there. Again, I'm just kind of guesstimating my best. And that is my orthocenter. And it is outside of my triangle. All right, I think you might have to draw one like that on your homework. So I just wanted to kind of talk through that with you. Yeah.
The right triangle is on.
Uh-huh. Yep. It's on. Not inside, not outside, it's on the triangle. Okay, any other questions for me? Okay, I'm gonna stop this recording.